Welcome students. Today we are going to start with the firewalls, which is the last topic of your module 4. And in this firewalls, we are going to see how many types of firewalls are there and how it is going to be helpful for operational security and for IDS. So now let's understand what is the meaning of firewall. So now firewall is nothing but it is a type of cybersecurity tool. Okay, remember that is main important point, that firewall is nothing but it is a type of cybersecurity tool where it is going to be utilized for filtering the traffic on a network. Okay, that is the main that is the meaning of your firewalls. So this is a like cybersecurity tool which is going to use to filter the traffics on a network. Fine. So now uh, what is the other meanings of your firewall? We understood that it is going to helpful for us to filter the traffic on a network, and also it will be useful for us to separate the network nodes, because we know that we have the network nodes where the source node will be there and destination nodes will be there. So it is going to separate all the network nodes from external traffic sources and also from the internal traffic sources. When we are going to send the packets from one place to another place, that time the internal traffic source will be your source side, and the destination side will be your external traffic source. So we are going to separate all these nodes by using the firewalls. So why why we are separating all this? So that we can filter the traffics, okay, on the network, so packet congestion won't occur. And also one more thing is also there, it will also work on some of the applications. Okay, so this firewall can be a software also, can be a hardware also, and can be a cloud based also, anything. And these all firewalls are having different agendas, how they are going to work out on the network. So as I told you that this firewall is working in your internal side also and external side also. So if it is going to isolate any of the organizations from the internal network from your larger network, that time we have to allow some of the packets to pass. So if we are blocking other packet, then only we can pass our packets whatever we want to pass in between our public channels. So here you can see this is a diagram. So here in one way that is your administered network, and another way that is your public internet. So here what is happening, this side, the administrator network side, this is a trusted network. But inside your public, in the side of your public internet, that will be your untrusted channel, untrusted network. So what will happen? So here you can see the systems has been connected with the routers and also with the switch. So whenever we will these all are my internal organization, and in this internal network, this organization is isolated from the external part. So this is my administered or trusted network. So I have utilized a firewall here. So what I'm going to do, if I want to send any of the packets from one place to one source to the destination side, I have to cross through my firewalls. So here, why we want to use this firewall? I told you that this one will help us for the traffic, like to prohibit from the traffics, right? So why we are going to use these firewalls? So first point will be, we can prevent the denial of service attacks. So what will be that, how we are going to prohibit from all these attacks? Here the attacker establish the TCP connections. We know that whenever we want to send any packets, before that the source has to give the handshaking signal and to build the TCP connections. So if they are going to build the TCP connections, sometimes what happens, instead of source, the third party will build the TCP connections, and there will be no resources like a real connectivity. Okay, from the real connections there will be no resources. So from that, if you want to prohibit, or if you want to demolish this attacker side, then we have to use these firewalls. One more way is there to prevent the illegal modification or access of internal data. So here what we are going to do, we will have the attacker will, what attacker will do, attacker will replace some of the home pages. Okay, so and it can modify some of the data. So there are many variety of service attacks are there. It can be a passive attack, it can be your active attacks. So again, passive and active attacks are many types. So by utilizing these firewalls, this is also one more attack, which is your modification of your internal data. So by using this firewall, we can modify, we can, like the attacker can, without using this firewall, the attacker can modify the data. But if I will utilize this firewall, then the attacker cannot modify my internal data, whatever we are sending from one place to another place. So here we can prevent the illegal modification of all the internal data, or we can prevent illegal access of all the internal data. These all are the 2 points. One more point is also there. It will allow only authorized access to your inside network. It will not allow the other authorized access. So there will be a set of authenticated users and hosts where it will allow to access within the network. Okay, so that is your internal organizations. And what are the types of firewalls? There are 8 types of firewalls are there. Okay, but you are not going to study all the firewalls, but you should know the firewall name. The first one will be your packet filtering firewalls. Okay, then circuit level gateways, then stateful packet filters which you are going to utilize, then stateless packet filters which you are going to utilize, then application gateways which you are going to utilize, then next generation firewalls, software firewalls, hardware firewalls, and cloud firewalls. So these things you are not going to use as per your syllabus, but at least these 3 firewalls, whatever we have given here in the slide, so all these 3 types of firewalls you have to use for delivering any firewall functionality, rather than being types of firewalls, architectures, or that things and all, it will be in the different story. But these things you have to learn, and you should know how to utilize in the firewalls. So moving towards the next slide, the first firewall is stateless packet filtering. So what we are going to do here, so how we are going to utilize these things. So here you can see the internal network has been connected to the internet via your routers. So here the router is present, and all the internal, what all are the data, what all are the systems are there, everything has been connected with your routers, and then it has been connected with the firewalls. So here what will be the question will arise, should arriving packet be allowed in or departing packet let out? So how we are going to utilize, can I receive all the packets from outside, or can I send all the packets from internal organization to the outside? Is it possible? So that things we are going to see here. So how we are going to filter the packets? So the filter, we are going to filter the packets packet by packet method. Okay, so one by one packet will come, then we are going to filter it, and this decision has to be takes place by using the technology that is your forward or drop packet. Okay, so how we are going to forward the packet and how you are going to drop the packet. So when we are going to use this methodology or technology, that time you should know the source IP address and the destination IP address, then TCP or UDP source and the destination port numbers. Okay, then ICMP message type, then TCP synchronization and acknowledgement bits. So here these all are the functionality, the like firewall functionalities which we are going to address through when we are transferring the packets from one place to another place. So the IP address for both source and destination has to be there, and then port numbers of both source and destination has to be there. Then the ICMP message type, which type of message you are sending, that has to be mentioned, and the synchronization bit and the acknowledgement bits also has to be there. So then how we are going to transfer. So here you can see the example. block incoming and outgoing datagrams with IP protocol field equal to 17. Okay, so this 17 is nothing but this is my incoming and outgoing datagrams with the protocol IP protocol field, that is 17, and also with either source or destination port number will be 23. So what will be my result? How I'm going to receive or I'm going to send the packets back? The result will be all incoming and outgoing UDP flows and the telnet connections are blocked. Because why? Because we want to authenticate while transferring the packets. That's the reason we have placed the firewall here. So here how we are going to do? Here, as it is 17, the IP protocol field and the destination port and all everything is here. So this is here, it has to be blocked because all the incoming and outgoing will be through your UDP flows. There is no TCP connections. Okay, as it is not there, there is no proper connectivity. That's the reason everything has been blocked. In the next example, you can see the TCP segment has been given with acknowledgement 0. So how, what will be the result of this? How we are going to prevent the result? So here prevents external clients from making the TCP connections and with internal clients. First, what we are going to do? First, with the internal clients and the external clients, the TCP connection has to be built up. That's here it has been given in the question that the inbound TCP segments is the acknowledgement is 0. It means that we are having the connectivity in between the TCPs. So internal clients and the external clients, but allows only internal clients to connect with the outsiders. So only my internal clients, those who are present here, they can have the connectivity with the outside clients. So through that my TCP connection will be established and I can send my packets. So here the firewall will work properly and it will not block anything as the TCP connection has been established. Here you can see the stateless packet filtering for some more examples. Okay, no policies, no outside web access. We cannot access the outside web browsers. So here what will happen? How we are going to set the firewalls? Drop all outgoing packets to any IP address where the port number will be 80. You can see in your system the port number will be 80. So here you cannot access. If it is 80, some of the web browsers will be there, which web browsers we cannot access. So the next one is, now the next one will be, there will be no incoming TCP connections except those for institutions public web server only. So here the institution will have the public web server where there will be no incoming TCP connectivity. So that time we have to drop all the incoming TCP synchronization packets to any of the IP instead of this IP address and the port number, because that we have already used for the web access. So in this way there will be some of the policies whatever has been given, and accordingly there will be the firewall settings for each of the policies. Okay, so that before we are giving any of the connectivity to the internet, we used to set up firewalls. So moving towards the next slide. Here how we are going to have the access control list, that is also known as your ACL. So here there will be the table of rules where it has to be applied from the top to bottom for all the incoming packets, that is known as your action and the condition pairs. So here this is nothing but this is a open flow forwarding table where you will have the actions like you are allowing it or you are not allowing it. So it will be in the two status, that is your allow status and in your deny status. So there will be some source address and IP address and the protocol has been used. So there will be source port number and the destination port number. So how you are going to allow? If you are allowing, then through the TCP connectivity you are going to allow, and the flag bit will be any kind of bits. Otherwise you can take the synchronization bit and the acknowledgement bits. So these all are some of the access control list. So moving towards the next one, how the stateful packet filtering, this is another type of your firewall, how it is going to helpful. So here we have to we should have the stateless packet filter, which will have the heavy handed tool. It will admit all the packets, okay, whatever will come from your source side to the destination side, and it will have the destination port number as 80, and the acknowledgement bit also will be set, and the TCP connection has to be established. So all these three points has to be taken care before sending any packets through your stateful packet filtering. And one more is also there, that is your once your track connection has been set up, that is a synchronization, and the tear down, that is F in. So here you have to determine whether the incoming outgoing packets makes any sense or not, because here we should understand that how we are going to use this TCP connectivity before. If you want to find out the status, then there will be the timeout inactive connections at firewall, which will no longer will admit the packets. So when there will be no access of packets or admit of packets, that time we can give the timeout, and within that timeout, if once a time will be out, then we cannot admit any of the packets. For this stateful packet filtering, there is also one more forwarding table is there, where there will be the same actions will be given, and there will be some source address and destination IP address and the protocol type. Similarly, for the port numbers of both source and destinations, and the flag bits have given. Only one thing extra has been given here, that is in the stateful packet filtering, that is the connectivity checking. So once if there will be no connectivity, you can put the cross mark. If you have the connectivity, then you can put the tick marks. Now next one is your application gateways. So how we are going to utilize this application gateways? The filter packets on application data as well as on IP, TCP or UDP fields. So you have to filter all the packets on application data by utilizing this kind of fields. Example, it allows select internal users to the telnet outsiders. Here you can see the diagram. This is isolation organization where many hosts has been connected with the switches and the server has been connected with the routers. So here suppose there is a built up with the telnet session. So the host to gateway telnet session has been taken place over here through the switch. This is known as your application gateway. And if you want to have the gateway to remote host telnet session, then you need to connect with the routers. Okay, so in this way you should use this application gateway as a third party, and you are going to give the connectivity to that, and again next you are going to connect with your routers. The same thing has been written over here. In the first case, you have to you require all telnet users to telnet through the gateways. First you have to give the connectivity. And for all the authorized users, the gateway sets to be the telnet connection to the destination host. It means it will have the two connectivity, because the gateway will have two connectivity. You see from here, this is incoming side, this is outgoing side. So this gateway, application gateway, will have the two telnet connectivity, and the router filters all the blocks of the telnet connection that has not been originated from this gateway, and sends the connectivity towards here whatever is connected with the gateways. Otherwise it will not have the connectivity. In the next case, what all are the limitations of firewalls and gateways? So here the first one, you can see the IP spoofing. So here this question can come for your 4 marks of question. What do you mean by IP spoofing? Here the router don't know if the data really coming from the claimed source or not, because many times the data can come from the third party, and they will be saying that like it has come from the original source, but that is very difficult to know that really from which source it has come up. And also some of the multiple applications which is necessary to have the special treatment, and each will have the own application gateways, and here the client software must know how to contact the gateways. If they don't know how to contact the gateways, then it will be very difficult. And to contact the gateways, they should have the IP address of all the proxy in the web browsers. They should have the IP address and the port numbers. And also these filters often use all or nothing for policy for UDP, because we have used many forwarding table where there have been the policies. So how we are going to have the settings on firewalls, so that filtration should happen here. The next one is your trade-off. Here the degree of communications with the outside world, how you are going to taken it up, and how the level of security you have been provided. All these things has to be taken care by utilization of firewalls. Many highly protected sites still suffer from these attacks. Some, because these attacks you never know that how it will happen to your site, so it is very difficult to know. But some of the percentage or performance we can increase by utilizing these firewalls. Now you can see the one more concept, that is intrusion detection system. Here also we have been used the packet filtering concept, where it will operate on your TCP or IP headers only. There will be no correlation among your sessions. So this intrusion detection system, in the short form also it is known as IDS. It will have the deep packet inspection. It will go inside the packet contents. It will not check only the length of the packet, but it will go inside the contents of the packet. It will check all the characters, strings, whatever the data has been given there, and what all are the packet has been used against your database, like your virus or any kind of your attackers, because it has to examine all these correlations to hide the data from the multiple attackers. And also it will have the port scanning, then it will have the network mapping, and also it will have some attacks. It has to check for the attacks. So how this intrusion detection system works out? We know that if there will be three network system, the firewall has been connected in this way. So here where we are going to put up this multiple IDS sensors, we can put the multiple IDS sensors in between the server and the switch. And here also you can see this is an internal network. I have put the IDS sensor here over here, and also for this network I have put the IDS sensor over here. So you can put the multiple IDS in different types of locations of inside one of the network, to check all the varieties of you can do all the varieties of your all labels of checking here. And also this network security, if I will summarize everything, so this is a basic techniques on your cryptography, where we are going to work on symmetric and asymmetric keys. And also it will have the message integrity. It will work on your endpoint authentications. Endpoint authentication in the sense it will have the connectivity into the host, and also it will have the different security in terms of your mails, and securing all your transport data, IP securities, and all the variety protocols. And then also it will operate on the security on based on your firewalls. So this is everything about your firewalls from your module 4. Hope you have understood this topic. Thank you.